In this episode of Voice of the Sea, we're out planting sea urchins in Waikīkī and visiting the world's largest and most successful sea urchin hatchery. Invasive algae are overgrowing reefs, outcompeting native limu, and destroying fish habitat. To combat invasive algae, the Division of Aquatic Resources has been outplanting urchins in Ānuenue Bay since 2011. In 2020, the Urchin Biocontrol Program expanded to the Marine Life Conservation District in Waikīkī. Today is Outplanting Day, and we're here at the Ānuenue Fisheries Research Center with Marine Resource Specialist Wesley Dukes and Aquatic Invasive Species Biologist Kimberly Fuller.
Right now they're suiting up to bring 2,800 native sea urchins that were raised in our facility out to the Waikīkī MLCD. Each diver will take a tray on a boogie board and swim out to target the hot spots of algae. We target 2 urchins per square meter of algae. For this project, we are slated to put out about 105,000 urchins over a 3-year period. Today's outplanting will bring us somewhere in the neighborhood of 87,000 urchins that we've outplanted. We monitor 2 times a year for the invasive algae, and we generate maps of where the algae is and density of the algae. From those maps, we are able to predict where to place the urchins to be most effective at grazing the invasive algae. We chose the collector urchins, 1, because it's a native species, 2, their spines are short and easy to handle.
Aquatic biologist with the Division of Aquatic Resources, specializing in aquatic invasive species.
So what are the kind of big issues that you're concerned about?
Well, one of our major ones is invasive algae. That's one of our main projects, and this urchin biocontrol is the only successful biocontrol project like this in the state. When we're outplanting those urchins, we're really targeting the dense invasive algae patches, and particularly where the invasive algae is overgrowing the coral.
The urchins that you're putting out, they will eat this invasive Acanthophora?
Yes, they eat the invasive Acanthophora. The other algae that we're targeting is gorilla ogo or Gracelaria salicornia. There's also another invasive called mudweed. This is called Avranvilia lacerata. This, unfortunately, isn't the favorite of any herbivore, which is why it can be pretty impactful. In Mauna Lua Bay, Malama Mauna Lua is doing manual removal, and so that also could be a way, kind of just taking care or gardening a certain area to restore it. We went over the invasives, but I just wanted to point out a similar native. This is called Codia medulli, and the Hawaiian name is Waiwaiole, and it looks very similar to gorilla ogo, but you can tell the difference is this is spongy when you touch it. It's also a lot more dark green in color. So gorilla ogo can kind of vary. It can kind of be almost yellow to this middle tan color to dark brown. Waiwaiole is squishy and more green, and Gracelaria is more rigid. Once an invasive species becomes established, it's incredibly difficult to manage and control, and if it's very widespread, it's unlikely to become eradicated.
How do we prevent invasive species from getting established in our nearshore environment?
Well, so something we can do on an individual level is clean, drain, and dry. So cleaning our gear, our tabis, our fishing gear, our kayaks, our surfboards, just making sure you're cleaning between areas. Because certain algae, invasive algae, are only present in certain areas. For example, in Ānuenue Bay, that's a smothering seaweed that's only present on Oahu on the east-northeast shore. So we really want to prevent, say, if you were, having fun in Ānuenue and then you came to a neighbor island, but you never cleaned your gear in between, you could be a vector of spread.
The University of Hawaii's Sea Grant College program focused on Hawaii's coasts and its communities through sustainable development, safe seafood supply, sustainable coastal tourism, hazard resilience, and healthy coastal ecosystems. Hawaii's Sea Grant.
We're at the Sea Urchin Hatchery at the Ānuenue Fisheries Research Center on Sand Island, talking with hatchery lead Dave Cohen and larvae rearing expert Matthew Lewis, learning about the types of spawning techniques they've developed for sea urchin aquaculture.
This building, the greenhouse, is the main building. This is where we do the grow out of the sea urchins. So we grow them from the time they're ready to settle. We bring them out here, they settle down, they become sea urchins. And then we groove them into these tanks over here where they grow for anywhere from 4 to 6 months. When they're 15 millimeters in size, we harvest them and we stage them in these tanks right here. In a typical year, we'll outplant about 50 to 60,000 urchins. That's about normal for us. This year, we're looking at outplanting probably 150 to 200,000 urchins.
That's a big jump.
It is a big jump. The staff has done a really good job of culturing our phytoplankton, the food that we feed the larvae. And the larval rearing team has done a great job of just making sure that everything is flowing smoothly, keeping the larvae healthy. So when the larvae are ready to settle, when they're ready to metamorphose, the larvae are healthy, they have nice full guts, and they can make it through metamorphosis. The techniques that we use here, many of them are common to other types of aquaculture. We grow phytoplankton just like you would in an oyster hatchery or a shrimp hatchery or a clam hatchery. Larval rearing techniques that we use here are very similar to fish larval rearing techniques, or maybe even a little bit like shellfish rearing techniques. There are several different types of invasive seaweed that have been growing in Kaneohe Bay. A Kapophycus seaweed, another one called Ukima, and then the one that we call Gorilla Ogo, which is Gracelaria salicornia. The urchins are primarily targeting the Kapophycus and the Ukima. In the early and mid 2000s, the Kapophycus and Ukima seaweed was growing so thick on the coral reefs in Kaneohe Bay that it was blocking out the sunlight and killing the corals. In some places, the seaweed would grow in mats 1 to 2 or even 3 feet thick. We expanded our project to Waikīkī about a year ago to deal with a hookweed problem that we're having there. And we're putting out urchins for them to eat the Gorilla Ogo and to eat the other invasive seaweed there, the Hypnium muciformis.
Hookweed.
The hookweed, yes. The reason we're growing urchins is to eat an invasive limu. The limu was introduced from the Philippines and or Indonesia, to where it's native. The urchins are native to Hawaii, but they're also native to the Philippines and to Indonesia. So we knew that the urchins, would be a very good chance that these urchins were going to eat that invasive limu.
Can you just describe the spawning a little bit? Physically, what are you going to do?
When we spawn urchins, the dive team goes out and collects urchins. They'll bring in 20 to 30 urchins, and we'll bring them into the hatchery and we'll let them rest for a while. Usually after 15 minutes to a half an hour, the males begin to spawn.
Just from being here?
Just from being here. And they'll require a little bit of a shake, and we'll collect the sperm from the males. The sperm in the water will act as a trigger for other males to start spawning, and then after about 15 minutes to 40 minutes, the females will begin to spawn.
We don't know if they're male or female when they first come in. There's no way to tell until they start spawning. Females will excrete an orange substance, which are the eggs. So when that happens, we'll give them a little shake. We'll put them upside down on top of a deli cup. They'll excrete the eggs into the cup, and we'll keep those all separate. So each female will have their own cup. Oh. We mix all the males together into one test tube. We'll have that 500 ml mixture of sperm and seawater. We'll take 60 mils of that into each 12-liter container. Wait 45 minutes, and then they'll fertilize. A run is about 26 days. As you get to like day 10 through the end, I'll be in here the entire day because they need more treatment as they get older. Not every run's the same. They have different stages that they'll hit about day 7, about day 14, about day 20 every run. This is called the larval room, LR for short. Think of this as like a womb or like an incubator. This is where we bring the urchins from egg all the way until they're what we call competent larvae, meaning they'll be ready to settle into a juvenile urchin within the next 10 to 24 hours. You can tell based on, observing them under the microscope whether the air is too high, the temperature is too low, the transfers, these buckets, it's too fast, it's too rough. Our flush, it's too fast, it's not fast enough. Unlike oyster larvae and shrimp larvae, these are very sensitive to the smallest changes in temperature, small pH changes, too much turbulence. Coming from an oyster and a shrimp background, right? All of the procedures and all the best practices have already been determined. They've been growing oysters for thousands of years. Urchin farming is pretty much new. I think we're the only hatchery that's using growing urchins for biocontrol right now in the whole world.
Next, we're in the lab with Patrick Gorong, who explains how the hatchery team grows food for the urchin larvae, which eat tiny algae called phytoplankton. So Patrick, this is sort of where you start your day. Tell me about what would happen on a typical morning.
I would come in and make sure that everything has air. Basically, that nothing's going wrong in here. And then I would drain out the bottom of these cylinders just so that anything that's settled into the bottom gets flushed out.
How do you know how much algae to keep culturing in order to feed all the larvae that you guys have outside?
We kind of have like a system that we've built kind of like through trial and error of like how much over a 10-day period, their growth cycle, how much they usually get to if you put them in a certain volume. All that has been put into calculation. We want to harvest it when the density is high enough, but then it's also clean. Because sometimes if it gets too dense, also other stuff start to grow as well.
How did you learn how to culture phytoplankton?
When I first started working here, we were trained on the routines for this algae room. But my first experience with aquaculture was working at PACRAC, Pacific Aquaculture Center in Hilo, when I was a student. This is our pure culture. They're just seed cultures. So we just leave them there until one of the lines get dirty, or like if it dies out or something catastrophic happens. This is the stuff that we use to start the 2-liter flask. The main thing in algae growth is, like with any other plant growing thing, you have to make sure that you're growing feed at the end of the day. So you don't want to put all your eggs in one basket. So that's basically what I'm doing up here. So I have 3 lines of keto and I have 3 lines of roto, and then these are benthic diatoms that we don't really use. When I started working here, we just had it and I just perpetuated, but these are the main ones that we grow. From my work experience and learning the routines, what to do every day, I start to notice the resemblance. Not really notice, but it started to click in my head that this is basically farming, which is what aquaculture is. It's like under agriculture when you're studying school. It's basically farming in the water. If you understand those concepts, it's easy to like know what you need to do, and it has the same rewards that you get from farming.
We are looking for a few heroes, mentors, trailblazers, innovators, a passion to change lives, spark curiosity, open hearts, and awaken minds, help students answer the question, who am I? This could be your calling, but this is no job. It's the journey of a lifetime. Be a hero. Be a teacher.
We're in the main grow room at the Ānuenue Sea Urchin Hatchery with Louie. taking a look at how the aquaculture team grows urchins from tiny free-swimming larvae to juvenile urchins, ready to be outplanted on the reef.
This is the ground area, and we have over 20 tanks here. Each tank can harvest, you can harvest about 5,000 to 10,000 urchins from one tank. We add about 250,000 larvae in here into one tank, and we'll get, a fraction of that to actually settle onto these plates, which has biofilm on them.
And a biofilm is just kind of like a biological bacterial kind of scum that
Correct.
they can attach to?
Yeah, it's a benthic diatom, benthic algae that will naturally grow onto these plates, and we condition them for that. So we'll actually let these plates stay in the salt water for about a month and a half. And they'll grow this biofilm. This is actually the food for the urchin once they settle onto these plates. So once they settle onto this substrate, it's actually food for them and environment for them to live.
And how big are they when they come from the larval room?
They're really small. They'll settle on here and they'll be like the size of a period in a sentence. They'll be that small. Wow. And they'll be sometimes there's hundreds on one plate. These guys are 7 months old currently, and you can see there's many different sizes. We'll actually harvest them at 15 millimeters, which is the size of a dime. We need to continually harvest out the bigger ones in order to get the smaller ones to grow and give them space to grow.
And when you say harvest out, where do they go next?
So they'll go into our barrels over there, and then they'll go out into Ānuenue Bay or Waikīkī. The scientific name for this species is called Trypnostes gratilla. It's a common collector urchin where they'll collect algae, rocks, and other things to camouflage themselves, and they'll put it on top themselves and hide pretty much from predators.
And how do they get it up there?
They actually have these 2 feet. They're like little suction cups, and they're like arms for them, and they'll stick it out, grab whatever they can, and adhere it to them. Their whole body's covered in 2 feet, pretty much.
And how big will they grow to?
We have an adult over here. This is about 5 years old. So they'll spawn from the top, and also poop from the top too. But their mouth parts are underneath on the bottom. And they have 5 rasping teeth, and they'll actually graze whatever substrate and limu they can. We have to monitor salinity, all the water quality parameters, salinity, dissolved oxygen, temperature is a big one in this greenhouse. In addition, we try to keep the tank clean of any excess limu that fall to the bottom. I'm happy to see the urchins get outplanted. I'm a local of Kaneohe and Kaneohe Bay, so I'm happy to see, my area taken care of.
Have you noticed a difference since the urchins have been outplanted in Kaneohe?
Definitely, there's a big difference. There's way less limu, invasive limu, than what we've seen in the past 10 years or so since this project started.
The hatchery team also grows its own macroalgae to use as feed for the juvenile urchins before they are outplanted. Lani Musselman shows us the tanks and the different types of native limu that they're growing.
This is one of the many tanks that we have to grow our limu, our seaweed in to feed all of our urchins. And in this tank, this is our Gracelaria Parvospora. It's a native limu, and we also have some ova growing on attached to it.
And you were telling me that the ova is just like a freeloader. You didn't try to grow it in here, but
exactly. So we grow ova in a separate tank, but sometimes it'll have its holdfast onto here. So we grow it simultaneously in this tank. However, that was not done on purpose, but because urchins love both of these limus, it works out very nicely.
And where do you get your original stock from?
Our stocks are from a giant sea tank that we have. It's an estuary tank that one of our workers here, Vince, grows for us, and he gives us the cleanest that he has there, and we use that for starters every week. We have our water inflow here. This thing in the middle with the mesh, that's our standpipe, so that just keeps the water level where it's at. And then we have a little ring of air to keep it tumbling, and that helps it grow and helps keep it clean rather than having it in stagnant water.
The standpipe is just a pipe where it won't the water goes in so that if it can't go above that level?
Absolutely, and this mesh is preventing any of the seaweed from going down the pipe and clogging it.
Gotcha.
We call this type of style of a tank, it's a tumble culture, and so every week we take about 4 kilos of limu that we clean. We just do a saltwater rinse in a salad spinner, very sciencey, and we just clean it around to get all the diatoms or any growth off of it, so it's just nice fresh stalks of the limu, and then we will start it with about 4 kilos, and depending the weather and how everything looks, if we're lucky, it'll just about over double each week, and then we'll take it all out, use it, hold it in a tank for feeding, and then we'll do the same thing with new cultures that we grab from Vince, and we'll start it with the 4 kilos, clean it, and we do that every single Thursday.
Would it be possible for somebody to grow limu for home consumption or for commercial sale so that we could eat these species of native limu that we like to eat, like ogo?
Absolutely, but we have to stress you cannot over-harvest from the wild. So for us, you know, we have someone that grows our starter cultures for us, so we're making sure that we're not depleting our natural resource out there. But if someone has a resource that's not grabbing from the ocean to over-harvest, absolutely they can have a little backyard aquaponics of some limu culture for themselves. I've pulled some samples of all the native limu we grow. If we want to go talk about it inside, we can.
Well, that'd be great, thanks.
Here we have 3 of the native species of limu that we grow here to feed our urchins. Limu is seaweed. And we have 2 different species of red algae. The first here is Gracelaria Parvospora.
May I touch it?
Yeah, of course. This one is also called ogo. This is one of Hawaii's most popular edible limus. This is what goes on all our poke bowls.
Yeah.
And over here,
oh, it smells so good.
This is our other species of red algae. It's also Lepe ohina in Hawaiian. This one is our really pretty limu. It's also nicknamed Pele's tongue. This one, our urchins are a little picky. This is not actually their favorite to eat, so we use this as a supplemental feed if we're ever running low on these other 2. Our last limu over here, this is our green algae. This is our Ulva fasciata. This in Hawaiian is limu pahalalaha. It's also referred to as sea lettuce. You can see why. This is our favorite for feeding because it's the highest protein content out of all these. However, it's a little bit harder to grow, so that's why this is used as our main feed supplement with these 2. And our ulva is actually, we use it as a settlement cue just to let our urchins know that this is a nice healthy environment, you can go ahead and settle now. We usually feed once a week, but we check in the tanks 3 days after the first feed to see just in case if they need any more, depending on the density in there. What I love best about working here and being a part of this project is obviously I love doing our limu culture, being able to feed our urchins, but the thing that I'm most excited about for this project is the whole aspect of marine conservation. We are allowing our coral reefs and marine ecosystems around the Hawaiian Islands to make a recovery from all this years of invasive species overgrowth. And being able to be a part of that, that's what makes me proud. That's what makes me happy to be here and what makes me most fulfilled to be on this track and on this project.
The Ānuenue Sea Urchin Hatchery is just one example of the innovative and important aquaculture work being done in Hawaii. The techniques developed by their team offer hope for Hawaii and other places where invasive algae is threatening ocean habitats. Find out how you can get involved, learn more, and watch other episodes online at voiceofthesea.org. Follow us on social media at Voice of the Sea TV. Mahalo for watching Voice of the Sea. Exploring Our Fluid Earth is the dynamic curriculum developed by the University of Hawaii's Curriculum Research and Development Group. The award-winning Fluid Earth and Living Ocean textbooks are now interactive and online. New activities, updated content, and a teacher community. Exploring Our Fluid Earth is now freely available. Find out more at exploringourfluidearth.org.